Okay, so welcome everybody once again for the second SEFI at Work in the series of the International Handbook of Engineering Education Research series. I'm Lynn van den Broek. I'm one of the co-chairs of the SIG of Engineering Skills, and I'm happy to introduce and moderate this seminar today. So the series of SEFI at Work in the context of the International Handbook is an initiative from the SIG from Engineering Education Research, led by Esther Ventura Medina and Tine de Laat. The focus of this series of SEFI at Work is to look into different chapters of the International Handbook of Engineering Education Research and how do they want to do it and how do we do it as SIGs. We give the floor to the authors of chapters, and it's just a joint effort by all the SIGs, so each SIG hosts a session or a chapter, and today it's the SIG of the engineering skills. So what will you get out of this series? We will give a guided reading from the International Handbook. You get some inside information from the authors directly. You will also get to know well-respected researchers and authors in engineering education research. And of course, one of the benefits of the SEFI at Work is to connect with people from the community. So as I said, this is from the SIG from Engineering Skills, which is co-chaired by Neil Cook and myself. Just some small information of our SIG, what we have been doing last year. One of the initiatives we had was developing or writing a position paper on skills. This one is almost finished, already read by the board, and we received some comments that we're currently reviewing. So we will be happy to share the position paper in the near future with the SEFI community. And what we actually see is that we have this, of course, this, as you all know, this shift in engineering education to focus more on holistic and adaptable skill set for our engineers. And we recommend to prioritize the development of different transdisciplinary elements alongside the technical and transversal skills. And one of the things that came out of the position paper is that we as a SIG are working on a handbook on transversal skills, which will be an ongoing project of the next 2 years. Just a heads up, because it's a busy month in the handbook series. So today we have Kerrie Douglas, who will be talking about the chapter of contemporary approaches to assessment of engineering competencies for diverse learners, which is chapter 31. And then next week, the week after, and the beginning of February, there are other chapters that will be discussed and shared by other SIGs as well. So if you're interested, don't forget to register for these ones. And then now it's time to introduce our speaker or author of the day, which is Kerrie Douglas. She's an associate professor of engineering education at Purdue University and also co-director of SCALE, which is a large Department of Defense workforce development project in secure microelectronics. In that role, she leads the education and workforce development across 33 universities in the US. She's passionate about modernizing engineering education and also preparing learners for their professional work. Her research is focused on improving methods of evaluation and assessment in engineering learning contexts, and she works on assessment problems related to fairness, how to support learning goals, and being work ready. She has been the primary investigator or the co-PI on more than 60 million of external research awards. And in 2020, she received an NSF Rapid Award to study engineering instructional decisions and how students were supported during the time of emergency remote instruction due to the COVID-19 pandemic. And then in 2021, she received the NSF Career Award to study improving the fairness of the assessment in engineering classrooms. She advises a vibrant research group that includes 9 PhD students, a postdoc researcher, and 2 undergraduate research assistants. She's also a mom of 4 kids and 2 cute little dogs. And in her free time, she likes taking her family or advisors on hiking and going to baseball games. So Kerrie, I think the floor is all yours now.
Wonderful. Thank you so much, Lynn. And thank you to the SEFI SIG for organizing this series. I am very excited to be here with you all talking about the chapter. So with that, I think, we'll get to it. So this chapter, Contemporary Approaches to Assessment of Engineering Competencies for Diverse Learners, is about designing assessments of engineering competencies that can be used in conducting research across different cultures and in multicultural classrooms. So since the talk is centered on the book, the talk is centered on the book, and I co-authored that with Doctors Melina Oliveri and Knut Newman. I'm not going to go through and repeat everything that the chapter goes into in detail, but rather I'd like to highlight some of the key points and have a conversation with you all about what some of these ideas mean. And so I'm hoping that as I ask questions, you'll feel free to speak up. So earlier in the week, we looked and it looked like there was only going to be about 33 people. So I thought, oh yeah, we'll have some conversations. And then this morning we learned that there's a lot more of you that joined. And so I'm super happy about that. We're still going to try to have conversation. When I ask questions, they're not rhetorical, they're genuine. And so please unmute yourself and talk, and let's see if we can capture different ideas, and we can give the floor to multiple people to sort of discuss some of the ideas. So please participate. Otherwise, we could have just read the chapter, right? So let's use the time that we have all together to have a real conversation. So my hope is that we'll start a conversation here, and that this conversation will continue in our research and in our meetings at SEFI and at the other societies when we get together. So if this conversation, things we talk about are helpful or particularly interesting to you, then definitely I encourage you to go read the chapter and look at all the references and kind of see where some of these things are coming from. So now to it. For assessment and then last thing, I guess, any of you that are comfortable turning your video on, I would love it, just so I know I'm speaking to real people out there, and I love seeing all your faces. Like I'm here in West Lafayette, Indiana. It's just after 9 a.m, I guess. There's snow all around me, and I'd rather look at your faces if I can. I know some of you, it's quite late. You're probably at home. So anyway, to the extent that you're able or comfortable, maybe you're in your pajamas and you don't want to, but if you're able to turn your camera on, I would love to see some smiley, real faces out there. So, all right, now on to it. So for assessment to be useful, it needs to be aligned to the priorities that we value. And my work is particularly centered around assessments that are aligned with competencies that are essential for being effective in the workforce. So when we think about that, my question to you is, what are the biggest priorities for preparing engineering learners or students to be ready for the workforce? So what do people think? Like, as you're thinking about this, like, what are the biggest priorities? So please, you can start. There we go. Gavin, you're the first one out of the gate. Go ahead and unmute and say something.
Yeah. Thanks, Kerrie. I think I'm a program director for a bachelor engineering program, by the way. So I think it's the ability to realize where your competence ends and to ask for help. Mm-hmm. So like the ability to develop yourself when you get given tasks that you can't do. So to know your limits and then to collaborate.
Right. So there's some like awareness of where you're at and being willing to ask for help and collaborate. What are some others? India Palmer, go for it.
Yeah, I mean, I would love to say that the biggest priority in my mind would love if it could be sustainability. But I think it kind of comes back to what you were saying before about the the conversations, being willing to ask those questions and have those conversations, because they can be quite complicated and that kind of thing. So I think it does lead on from that previous point.
Yeah. Awesome. Yes, definitely. I think even from the last SEFI conference, right? Like the sustainability, or I guess it was 2 years ago, maybe was the theme was around sustainability. But anyway, this is definitely of global importance. And I see that in the chat, Allison Hutchison said, yes, sustainability, we seconded that. And then she also previously had said that critical thinking skills and literacy. So I think based off the other, it sounds, Allison, like you're thinking even like information literacy, like being ready to, you said hesitant or resistant to reading, for example. Yeah, like being willing to like dig in. Absolutely. What are some other global priorities? Oh, I know there's more than like 2 or 3. And you all know I'm a professor, so I can sit quiet for a while. Wait. As we... Gavin, hey, go for it. You're on a roll.
Sorry, if no one's gonna volunteer, I wait a bit.
I won't start cold calling, but some of you I know. So you know.
I come from outside the engineering discipline. I was trained as a chemist. And one of the things I think is interesting is ethics. Because a lot of professional bodies that govern the engineering profession talk about ethics all the time. Members have ethical statements. And yet when you end up in work, because that's where mostly engineers are, they're all in these companies. How does a personal ethical framework relate to what the company you're working for is actually doing?
Right.
You know, and consider it is huge, because you know, you've got, if you work for Tesla, for example, it's quite a complicated ethical thing for you, I think, if you at the moment, or a oil and gas company, for example.
Absolutely. Absolutely. Yeah, ethics is huge. For those of you who attended SEFI this last year, that keynote from Donna Riley, all about this issue. I mean, it's yeah, ethical reasoning and what you do on the job is, I mean, preparing learners for when their values may not be exactly what their employers are. I mean, that's, gosh, it's so crucial. Okay, so Hoberg Martin, is it Hoberg Martin or Martin Hoberg? You're on the, you can talk or unmute. You're up.
Now you hear me, huh? Martin,
yeah, there we go. Now I hear you.
Hi, greetings from Switzerland. It's not at night yet, but just the background. I think team working in teams is still an issue, given the fact that people are graded piecewise, everybody for himself. How do you teach teamwork and interdisciplinary teamwork on top of that?
Oh, yeah, for sure. The teaming aspects. I mean, that's, when we talk with employers, I mean, this is a huge skill for them, you know, working together, and even in like multinational teams, like being ready to interact. And not all engineers like interacting with other people, right?
Yeah,
like
then they have the intercultural differences on top of that.
Right. Yeah, there's a lot there. That is crucial. Dirk Boker. And I apologize to everyone that if I am butchering your name, so you can correct me when you go to speak.
That's okay. We are used to that, at least in my case. So it's Dirk Bochar, actually, from Brussels.
Oh, Bochar.
Good afternoon.
Well, very nice. Nice to meet you.
Nice to meet you too. Martin is one of our participants in the working group on assessing engineers from all over Europe to improve their professional mobility so that they can work in other countries. So there are a couple of people around the table here that I know. It's nice to join you, and congratulations for taking this initiative. Now, the question you bring up here is one that is on the agenda also of the World Federation of Engineering Associations. who are actually at the moment organizing 16 webinars in a row on anti-corruption in the construction business. And there was a workshop yesterday, and I found it strange that actually the anti-corruption or any course around that is not part of a mandatory curriculum, be it bachelor or engineering, or master engineering courses in the US. I'm not sure if it's actually on the curriculum in Europe, but I believe anti-corruption, especially in the construction business, and then more in particular certain parts of the world like Africa, but also in Europe, I believe, is an issue that students should be made acquainted with or familiar with. And I think this is not probably, I'm not sure, you're the academics, but this is not something which is fully automatically integrated in the engineering curricula, I believe.
Yeah, I mean, when you stop and think about it, it's rather disturbing, actually. I mean,
Yeah,
it is,
yeah.
right? Like I think about that. Like it's so okay, we got 2 more questions and then we'll go from there. So we have, I think Neil was first and then we got Allison.
Hi, Kerrie. Yeah, I got a very short point then, because there's so many. I think there's so many priorities, but I think one of the biggest ones for engineering students is actually to unlearn assessment. I think it's really important to get students to recognise that the environment they've been in and the way that their work is assessed is completely different in the workplace. There is no assessment, there is no grade awarded periodically and with prediction, with feedback. And I think that's probably them to understand. I mean, this isn't my quote. I've read this a long time ago. I can't remember where it was, but nobody will pay you to solve a problem that's already been solved. And I think that's that always sticks with me, and that's what I tell my students. Thank you.
My goodness, Neil, you are talking to the right crowd. I just know it. One of the biggest challenges here at my institution is that the College of Engineering is rather selective. And so the students that we get are used to being in the top of their class. Yeah. So that means that they are very much used to always getting straight A's, like top marks. And they know how to do really, really well on multiple choice tests.
Yeah.
They know how to get good grades. But as soon as we give them open-ended problems, when we give them projects or things that feel less inside their control of what they've done, that's so performance, they get really uncomfortable. Yeah. And there's no multiple choice test when you're working as an engineer that gets your work done. Like you have to be able to use that knowledge. So right on, spot on. Okay, Allison, what do you got for us?
Okay, I just wanted to quickly jump on to something that was just said about integration within the curriculum, because I often find that in my College of Engineering, things like ethics, sustainability, I myself am in a communications program, these kinds of things are often sort of shunted to the side by faculty, at least by, I from my observations, a lot of faculty in engineering think this is not something that I can or should teach. And it takes up time from the technical curriculum. And so, ethics, somebody else can do that, right? So I think that topic of authentic integration into the curriculum is super important. If we're going to assess any of these things, we have to take responsibility for them. So it's one of the reasons why I'm very, very excited about the upcoming SEFI collection on transversal skills in the curriculum.
Yeah, absolutely. Yeah, we can identify the priorities that they also have to be implemented in the curriculum. Okay, last comment we're going to give to Hoberg, and then we're going to move on.
Yeah, but I would like to raise the question whether it's really a matter of integrating something in the curriculum to address it explicitly in form of teaching, or isn't it just the didactics that you have to think about how to teach something, not what?
That is, yeah, okay, we could talk for a long time about this. that question, like how to get it in, like what's the way to do it, right? All right, that's food for thought, everybody, because that is a very That's a very good point there. All right. Thank you. All right. So the things I kind of highlighted from how I'm thinking about things or what I'm seeing here, I think most of these were called on by the participants, that we're talking about deeper levels of understanding, not just having that rote memorization, but really knowing what's important there, the depth of it, more depth, and not like just shallow, but a depth of knowledge. The importance of fundamentals so that the learners can, or the engineering, when they're professionals, they can pivot as the workforce demands pivot. Like when you have a deep foundation with the changing tides, then you're able to make some pivots as as workforce needs change. As we mentioned, the professional skills, teamwork, leadership, the critical thinking, creativity, ethical decision making. I like, anti-corruption, making it more explicit, like not just ethical, but like anti the corruption. Empathy is becoming a really big priority in several pockets, I think, of the globe. So we're becoming aware that engineers make decisions that have consequences on society. I think we really can't ignore that in the preparation of them. There's also all of the technological and engineering practices. So, being able to do like evidence-based design and having modeling skills, like engineering in a lot of areas, in a lot of ways, is becoming more and more data science driven. So there's that programming and being able to do simulations, like model-based systems engineering. There's all these practices and technologies that are getting used as things are so fastly advancing. There's also cross-cutting concepts, like concepts that the student, like, they're just going to keep seeing them in different contexts over and over, like what size and scale, for example, like what it means at a macro level, micro and nano. This changes a lot. Like issues of sustainability, what it means in one context, and then continuing thinking about that. Power is another example. There's also, we talked about like just preparation to work in multinational projects with multicultural teams. Maybe that kind of goes under professional skills, but and then there's also this increase on broadening participation of who can become an engineer, and really the increasing the diversity of engineers. So these are kind of some of these recent global shifts in engineering education, and any competency in engineering cannot be separated from the learner. It can't be separated from how they know and their ability to use that knowledge. It's not just, as we said, like it's not just this memorized thing, but it's actually the doing. And if you notice, nothing on that list is easy to measure. Like nothing on that list is like, I have people say, oh, you can't assess critical thinking, or can you really assess, communication, or can you really, teamwork? And the answer is yeah, you can. But it's not easy. And it requires some thought. So advancing knowledge of how to prepare learners for the demands of the current and future workforce really requires new assessment approaches. So there's a lot of research, going on to support these different these different priorities in engineering education. And for us to really advance what's known about any one of those areas and how to prepare learners for them, we need to have assessment tools that are robust enough to make strong claims from the results. And so this really becomes a research challenge. And the historical assessment approaches focus on one concept at a time. So, most of us, one of the very first things when engineers start learning to do education is, Often they learn about something like revised Bloom's taxonomy. They learn to write, learning objectives. In the US, they're often said to be SMART. Like, they got to be specific, measurable, realistic, and timely, I think. But they're wanting everything to be very, very measurable, very succinct, very clear. Well, I think for a course and for an instructor, once you get your class overarching course goals, and then you do that, I think that probably does help make things clear. But when we're talking about assessing actual competencies, these things are not so neat and clean. And none of these actually exist in the real world apart from other aspects, right? Like I can't actually do teamwork and be an effective teaming member if I don't know my disciplinary content, if I don't know, how to do my modeling. And so like you can assess me on my teaming skills and you'll find out about my just teaming. But really, if we're talking about the workforce, it's the ability to do that with all your other knowledge and skills. And so what I'm sort of advocating for is that we think about things more holistically of what is that competency? What's that look like? How do learners use their knowledge from all these different things together? And that becomes really almost like a multidimensional competency or complex engineering competencies. So the purpose of the chapter really was to provide a framework to do this, to guide the design and validation of assessment instruments that were capable of measuring multidimensional competencies when a particular group of learners or other group is being assessed has also the diversity in terms of their culture. So just some important definitions because I'm sort of an assessment geek and I want to make sure that you all, I understand not everybody spends all their time thinking about these things. So just so you kind of know, we get on the same page, I'm going to use some terms and validity is an evaluation of the evidence that supports the assessment score can be actually interpreted and used as intended. And so validity is not, or validated, it's not a property of the assessment, but it's really what we do with that result. Because you can have a really solid, high quality assessment instrument and use it in really invalid, inappropriate ways. And so it's about the evidence that we have that, yeah, we can use this score the way we want, the way that we've intended. This actually is a measure of X. So, and validity really starts with the design of the assessment. And so today we're going to walk through how to, from the very beginning, start laying that groundwork for having a solid validity argument for the use. And so I've got other writings that I can point you to that talk more about validity and validation, but that wasn't the sole purpose of the chapter. So reliability is essentially just it's consistency and precision of the score. So I think this one, it's, if you have the same amount of knowledge and I give you the same assessment multiple times, then, in that hypothetical theoretical space, you would get the same score every time. Now, in the real world, what we know is, as soon as you see an assessment, the next time you see it, you're going to do better probably, or at least you're going to, it's going to trigger something. So there's an intervention. But the idea here is that there is consistency and there's a lot of ways of measuring that. Fairness has been defined in a lot of different ways, and it's a very broad, there's no one general, widely accepted definition. But for our purposes, it's the consideration for how the assessment itself and that assessment process enables all learners to adequately demonstrate what they know and what they can do. So what we're saying is that fairness means we're actually measuring what you know, and we're not putting any barriers or hurdles to you showing that. So this can happen when we use language that maybe like colloquialisms or, things that someone who's not native in that language may have no clue what it means because it's not a literal meaning. This can happen in all sorts of ways. The unfairness aspect can happen in all sorts of ways. And then, as I mentioned, like I use the term multidimensional competency and complex competency somewhat. Sometimes I use them interchangeably. So I'll try not to do that to confuse you today. But multidimensional competency is really the ability to use that disciplinary and or technical knowledge alongside the skills and engineering practices to make engineering decisions. And so this is really that doing engineering aspect, like being competent to demonstrate the combination of all these things to actually use them. So one of the most promising, I think, models that's out there right now that is called evidence-centered design. And it was originally designed for a high stakes, large standardized testing program. However, Jim Pellegrino and his colleagues in the original Cambridge Handbook of Engineering Education adapted it to make it more accessible for an engineering education research community. And so how this is specified then from that work is that assessments really are composed of three parts. The first is the student model, which is really thinking about what knowledge do you want the students to have and how do you want them to actually use it? And so really like taking the time to articulate this. And then the other is the domain model. And this has to do with like evidence, and the evidence both in terms of how you think students show you evidence, and then also the evidence you'll need to use that assessment instrument the way you intend. Then the task model is, the actual, how do they show this evidence? What exact tasks are going to elicit this from them? Like, how do we elicit these? What kind of task would be necessary? So, as I mentioned, I find this like, a really promising model for developing assessments. My one critique is that knowledge is socially constructed, and none of these are in isolation from a learner's environment and the culture and their ways of knowing. And so really, if we're not taking into account the diversity of the learners, then we're running a high risk of creating assessments that are going to have results that have mean group differences for the minoritized groups that we are assessing. So if we don't have that specific consideration for the different groups of learners that we're going to assess, we're going to end up assessing based off of what we think the dominant group how they know. So that goes to my point, and kind of the main thing about the chapter is that, I think we got somebody with their microphone unmuted. There we go. Thank you, whoever you got that under control. Okay, so there is no such thing as a culturally neutral assessment. And learners are not blank slates. They bring their own experiences and knowledge into the classroom with them. And what one knows and how that's known is often based on our lived experiences. So for example, I was talking with a colleague who and from Latin America who did her PhD program or not PhD, sorry, who did her undergrad engineering program in Northern America. And on an engineering exam, the very first time she ever had to think about snow was on an assessment question. And the assessment question was asking them to calculate, it had to do with the, gosh, now I can't remember the whole context, but it was essentially the snow, how the snow on the roof and like making sure that the beams and the supports were going to be able to support this. And so here she's someone from Latin America, never thought much at all about snow. And then is now having to, on an engineering exam, consider snow and how it melts. And like, the snow weigh? How much does it weigh? Like thinking about all these things. Well, anyone who grew up in North America or upper North America especially had already had a lot of awareness and experiences with snow, and that probably didn't trip them up at all. But that one assessment question could, really kind of like stressed her out, knocked her off, and, affected her the rest of the exam. And I'll also add that we communicate who belongs and who doesn't when we do things like that, right? Like if someone is taking an assessment and they say, nothing about this represents me, or I don't even know about this. I mean, the message is essentially like, well, that's because we don't really have people like you, right? So along with this, like language is a tool for learning, and different languages provide different opportunities. I can talk lots about that. I'm sure this group is like very knowledgeable about how, your own language has phrases or multiple words for something that the English language maybe just doesn't, or that it's hard to translate because there's not an exact same thing. So these cultural influences provide opportunities to learn, and they provide the context to what we know. And so if without direct consideration for the different cultures and identities that are being assessed, then the assessment is likely to represent the developer's culture and not the learners who are the ones being assessed. So I've done a lot of talking and we're already at 9:40. I'm going to give 5 minutes and let's just talk a little bit about this issue. Like, how does language and culture influence what and how you know? So does I gave the example, does anyone else have some examples about how their upbringing or their culture, like that they've interacted with someone from a different culture or different language that maybe understood things differently? All right, Sophia, thank you. Go for it.
Yeah, I have a similar example that we recently had with a student coming from Iran. We are from Belgium, by the way.
Yes.
And it was, a question, the context had something to do with, the yellow rubber ducks that children plays with, so it was in the context described, but also the student had no idea what we were talking about and got stuck just because the context was not very clear for that student. Yeah. So sometimes language is indeed something that we unconsciously, we're not aware that not everyone get the same meaning or understand it the way we think that it's quite obvious and clear, but it's often not the case. Yeah.
Yeah, absolutely. That's a great example. Yeah, thank you, Sophie. Emanuela, I think you're next. Oh, it's Shannon.
Hi, there are a whole bunch of us camped out here.
Oh, that's awesome. You have a SEFI at Work series party going on. I love it.
Diana just delivered a lecture to us. So anyway, I work closely with some Middle Eastern students who are studying in Ireland. And they said, a lot of times we know the concept, or we learned something about it, but we learned it in much different words back home. And so it takes us a while to figure out, oh, that's the concept. And then we're struggling so much. The teacher is writing so fast and not the whole word, just some symbols. And if we want to look it up or ask or text a friend to ask, what the concept is, to put it in the right schema, I guess, then it looks like we're not paying attention. And anyway, we lose the thread. So it's interesting to know that our students are really what their experience is like, that they're being conscientious and but just struggling to connect the body of knowledge they have from a different language and maybe even a different approach to teaching some of the concepts. And they're not starting with nothing, even though sometimes it might look like it.
Yeah. Yeah, that's excellent, actually. That's actually yeah, Shannon, I think you described exactly what I'm talking about. And I think a lot of us have engineering institution, or our home contexts are full of learners from different countries. And we have to take the time to actually, like, especially, I mean, I think it should be done in all classrooms, but I know not, I mean, that's not, I can't make that happen. But what I'm saying is, for us as researchers, if we're going to be using this to advance scientific knowledge, like we're trying to advance what's known, like we really have to take the time and understand, these groups. And, like, what is the international population? What countries are they from? And when we're developing the assessments, like having them engaged in reading the assessments, or taught, like when we know what it is that we want to study here. I'll go on to the next slide because this is kind of what I'm talking about. The student model, like as we're thinking about that disciplinary knowledge and the skills and the practices and like how these things are going to come together, actually talking about that with some of the students and the cultures that we're going to assess that are going to be in the non-dominant group, right? And I think the same thing is true when we have, neurodivergent learners, or students with different abilities, like without actually consideration for the diversity, then we're running the risk of just saying everybody knows the way I know. And then our research and then we're sort of surprised when we have these mean group differences and we say, oh, well, all the students from this X subgroup scored worse than all the students from this X subgroup, right? Like without fairness considerations, you can't make those kind of claims. You can't make group comparisons if you haven't established that it's actually fair for the people you're trying to compare. Yes, Venkatesh.
Hello, Professor Douglas, and
Oh
hello,
gosh,
everyone.
it's so good to see you. Okay, I didn't see
Yeah,
the last
likewise.
name. Hey, nice
Yes.
to see you. Okay.
Yeah, likewise. So actually, the one aspect regarding the language and the culture. So I'm basically from I'm right now in Germany, teaching here at FAU. So what I experienced is that most of my class students are come from different backgrounds. And for example, I come from India, and I know how the work, the undergrad education and the terminology, what they use there. What the students were facing and my colleagues here in Germany, what happened was that during a course, most of the time my colleagues teach in using different words and different symbols, which the other students would not be able to understand. And because of my exposure to how the things were taught back there, I was able to see that the students are not just bad, it's just that they don't understand what we are trying to say. So I think I just wanted to point out that it's very important for our exposure to the diversity also as a teachers to relate to the students. I think that should be the thing I just wanted to mention.
Yeah, absolutely. Absolutely. I think you're 100% on. And Venkatesh took class with me like many years ago, and I have not seen him since. So this is what I'm like, oh gosh. So anyway, it's great to see you. And as a professor now, that's wonderful. Okay. So the next, if I can get there we go. The next is that domain model and thinking about it. And so again, this is where we're thinking about how do the students show us what they know, right? And so this is like the kind of like, how do I know they can do this? What would it look like? And, and so just kind of taking that, what would this look like? And so we think, well, maybe it's going to be a project of some sort, or it's going to be, maybe at the end of a design project that they have a report where they specify design decisions along the way, or, and in that they articulate, some of the ethical reasoning, or, how all these things come together. Gosh, it is almost 10 till, and I really wanted to ask you the question of what type of assessments you use, and like what kind are you comfortable developing? Okay, like 2 minutes. Can just like 2 or 3 people shout out and just say, what kind of assessments are you most comfortable designing? I put so much pressure on the briefness, nobody wants to talk now.
Hey, Kerrie, it's me.
All right, Jason,
I'm at Purdue too. I just wanted to shout out that we are developing adaptive assessments. These are focusing on conceptual inventory questions, but I would love to be thinking about the more procedural knowledge, the metacognitive knowledge, and everything that was identified here that is important, but there aren't any really good assessments out there that I've found.
Yeah, thank you. Thank you. It's hard. That's the thing. When you get into studying some of these, you realize there aren't assessments off the shelf ready for you. And so then this becomes what you thought was, I just want to do my research. And then you realize, oh no, I'm going to have to do assessment research first. So when you get in that situation, you can be like, hey, Kerrie, can you look at this? Or like, I'm happy to do that. Great. I saw you raise your hand and turn the video on. So it's too late. You can't shut it off now.
Oh, damn it, you saw it. Hello, Kerrie. Hello, everybody. Yeah, I first raised my hand because I wanted to tell you which assessments I am using, but then I read, oh, I should be developing them, and that's not the case.
Oh, no. Tell me what you're using. That was the question. I'm curious. I want to know.
I'm very old. Okay, sorry.
Yes.
I'm very old-fashioned. I like oral exams. I really like oral exams. Talk to people and hear what they're thinking and dive deep into their reasoning. And indeed, in that way, you can discover if there are cultural problems or things like that. Because while talking, you see how they are reasoning. I really like oral exams.
Thank you. This is a huge difference. I think this is a cultural difference, by the way. And I didn't realize it until I spent time at UCL, because faculty, where they are, because faculty there were telling me that they do oral exams, and I don't know anybody in the States that does oral exams. And like, I was thinking about it from my own perspective, like how much it would stress me out. But it does, it's a whole other thing. Like, I think it's a cultural thing, So anyway, that's very interesting. Okay. Yes, Hoberg.
Yeah, the question is for me, would oral exams also involve showing and demonstrating something, or only talking about something?
How do you do it, Greet?
Yeah, is it just on the meta level that you start talking and explaining? But perhaps if you talk to somebody, please show me and do it for me. Yeah, draw a more Coulomb circle or something. Explain the shear stresses, and so they may be able to talk about shear stresses, but when it comes to showing something, demonstrating something, they're perhaps not as good. So how do you cope with that?
Yeah, we use both techniques in my faculty, but me personally, I'm using it to talk about students about the theory they learned and to discover how much I should what should be their points on the exam for the theory, not for the lab or for the exercises. The exercises, for example, are completely written exams.
All right. Yeah, thank you. I think this is kind of very interesting to me. I didn't even write in here oral. That's how much I'm still being an American and talking to you all about being multicultural. So, but yes, I should have known. Actually, I don't think that, I think maybe when I did the chapter, it was before the time I spent. But so here are some different ways of doing assessment that would elicit the combination where you're allowing learners to do something with their knowledge. And then I think the other question then is, well, how do you score them? And so sometimes people will say, well, yeah, I mean, I can give a portfolio or I can give some open-ended projects or, but then how do we get a grade? And so obviously, like, to me, I tend to go to rubrics, and there are different kinds of rubrics for different kinds of situations. Okay, so then the validation part, in terms of what people tend to think of, like at the end, like doing some of those, like how do we know we can trust the results, really requires consideration for looking at some of the measurement and some of those properties of the assessment to ensure that it isn't just introducing a lot of noise and that these are effectively capturing. So in the chapter, I'm going to just keep going because it's 9:54. In the chapter, we talk about which measurement model to use. And the main point here is that to use an assessment or make it really available for the research community, you need to have that evidence that it is trustworthy, that there, it isn't just arbitrary, but that there was a principled process and, we can trust that the scores or the results are something that we can, that's trustworthy. And so we laid out in here 5 different measurement model sort of categories. And again, the chapter kind of goes into a little bit more detail about each of these. Like there's performance-centered strategies, and these are probably what most folks are familiar with because this is sort of that like percent correct of the total. And then they look at proportions under what's known as classical test theory. There's ones that are more resource focused, and that's where we're looking at the latent variables and allowing for multiple variables underlying a student that would contribute to what they know, and also allowing for different constructs to be related within the assessments, which we know, like they are not separated when we're talking about multiple things. There's also structural equation modeling approaches, which will allow for comparison of the different relationships. And that can include both the measurement model as well as some regression models. It can also be used for comparing measurement models for different subgroups. Something I've become more interested in lately is the diagnostic classification modeling, where this is not trying to place learners in a numeric continuum, which all statistics is going to really kind of require some approach to normality. But DCM is more like focused on competency and being able to diagnose where along that competency that they haven't quite got or where they're really excellent. And then there's also emerging, and I think can't do justice enough right now for the process-based analytics strategies. And, we see a lot of that in some of the learning analytics and getting into like what students are actually doing as they interact with, simulation tools and other forms of sort of embedded or stealth assessments. Maybe we're having them do tasks online, simulations, and then being able to analyze what they're actually doing. So, so the point of the chapter, and hopefully pressing on you during this time together, is to advance the validity of the research and engineering education regarding what students know and can do, there is a need for new approaches for assessment with special considerations for the complexity of learning that we really are valuing and the diversity of learners. So in that effort, we've provided a guide to sort of help folks start to struggle and think through what that means for the topics that they're interested in their research. So, thank you. Oh, and I'll give you I was going to say, I can give you, I think my email is provided at some point, but.
Yes. Thank you, Kerrie. And I will also put in the link to the handbook in the chat, because I think today you have talked a lot about why it's important to look at assessment in a different way, what or how you should assess it, and in which way you can do it. People who are really interested can go and read your full chapter where you explain everything in detail. So if you haven't read it, please do so, because I find it really interesting myself. So, and maybe there's time for 1 or 2 small questions. If anybody has one. And if not, I think we can thank you.
I have them all mystified, that end with the measurement models. They're all, gosh, now I don't know what to say. We were.
So let's say thanks to Kerrie for presenting, giving us some food for thought about our own assessments. And thanks everybody for joining, either alone on your computer or in groups. Have a nice day further, and see you all soon in the next seminar.
Yes, thank you all for coming. It was my pleasure to be with you and get to know some of you and hear your thoughts. So.